All right, hello everyone. Welcome back to our notes videos for Unit 8. We are on Unit 8, Notes 4. Today we're talking about solving radical equations. Our objectives today are simplifying radical expressions, which we've been doing for a week now, solving equations, which we have done for a long time now, but we're going to be solving equations with radicals today. So those are the three things that we really need to be able to do. In order to solve radical equations, we have a step-by-step process here. We're going to, first step is to cancel the constant that's outside the radical by adding or subtracting. So that's getting rid of whatever outside the radical. Our second step is to cancel the coefficient in front. So that's going to be dividing or multiplying by the number that's in front of the radical expression. And these two things are really just to isolate the radical. We're trying to isolate the radical. For number 1 and 2. After we've isolated the radical using steps 1 and 2, the next thing we have to do is square both sides of the equation. That's going to cancel the radical. That's going to make the radical disappear. And then we'll be left with an equation to solve for x. We have to solve for the variable. Okay, so that's our step-by-step process, and we're going to be using that throughout the day today. One thing that I do want to discuss is just the square root equaling a negative number. The square root of x only has a positive solution. So when we have something like x squared, if we had x squared equals 9 per se, when we take the square root of that, our two solutions are -3 and 3. But when we're looking at this x under the radical, this is just x to the first power. Here we had x to the second, which is why we got two solutions, but this is only x to the first, so there's only one solution and it's going to be positive. So that's what we're looking for today. In number 1, let's do some practice questions. In number 1, we have the square root of x minus 7 is equal to 0. So the first thing I need to do is cancel that constant that's outside the radical. That's the -7. So to do that, I'm going to add 7 to both sides. That leaves me with the square root of x, and on the right-hand side, 0 plus 7 is 7. So now I've canceled the constant. The coefficient out front, there isn't one, so I don't have anything to divide by. Then the next thing I would do, now that my radical is isolated, it's by itself, the only thing on one side of the equal sign is the radical, now I can square it. So this whole thing gets squared. But remember, whatever we do to the left, we have to do to the right. So I'm going to also square the right-hand side. On the left, when I square the square root, those two things end up canceling each other, which leaves me with just x. That's what I want. That's my goal. And then if I simplify the right-hand side, 7 squared happens to be 49. The last thing we would do is solve for the variable, but the variable's already alone here, so that's my solution. X equals 49. Let's take a look at number 2. In number 2, I need to start by adding that 10. So I'm going to add 10 to both sides. That leaves me with the square root of x equals 10. And then the next thing I need to do is to square both sides in order to cancel that radical. Because again, squaring and square rooting cancel each other. So I'm left with just the radicand, or the stuff underneath. And then on the right-hand side, 10 squared is 100. I'd solve for the variable, but it's already alone here. So I have x equals 100. Let's jump down to number 3. In number 3, now I have a coefficient out front. Okay, so a couple of things that are different here. First of all, this +4 is now underneath the radical. So I can't get rid of that first because it's underneath the radical. Up in the previous questions, it was outside of the radical. The radical stopped there. But now it's underneath the radical, so I need to leave it. But I am going to divide by the coefficient. So if I divide by the coefficient, which is 3, that cancels that. Divide by 3 on the right-hand side. I'm left with the square root of x plus 4 equals 15 divided by 3, which is 5. Okay, now I can square both sides. When I square both sides, I end up with that canceling that, and the radicand, or x plus 4, is left over. So I've gotten rid of the radical sign. I'm left with x plus 4. On the right-hand side, 5 squared is 25. And then solve for the variable. I need to subtract 4, and I get x equals 21. Now, one thing that you could do to make sure that you've got this down, you could always plug this back in. If we plugged 21 back into our equation, we'd have 3 times the square root of 21 plus 4. That's 3 times the square root of 25. That's 3 times 5, which is 15. And that was the other side of our equal sign, so we're good. So you can always go back and check your answer. I want you at this time to pause the video and see if you can work on number 4. In number 5, we have the equation, the square root of 2x minus 3, and then plus 9 after that equals 5. So let's see what we would do here. I would start by subtracting the 9. When I subtract the 9 from both sides, I end up with the square root of 2x minus 3 equals negative 4. Now here's the problem that we talked about at the beginning. Since this is only going to have a positive solution, I'm never going to find anything that I can get to negative 4. So this answer right here is no solution. Now that the radical was isolated and I have it set to a negative number, there's no solution because I don't have a negative solution to those. Let's try number 6. In number 6, I have the square root of 3x plus 1, and then minus 2 outside is equal to 6. So I'm going to start by adding the 2. That leaves me with the square root of 3x plus 1 equals 8. Now the radical's alone, so I can square it. I'm going to square both sides. This cancels that. I'm left with 3x plus 1. 8 squared is 64. And then I can finish solving for the variable. So I'm going to subtract 1. That's 3x equals 63. And divide by 3. And I get x equals 21. So there's my solution there for number 6. Let's do one more together in number 7. In number 7, I have 5 times the square root of x plus 1 is equal to 5. So let's pull that out, and I'll move my page down a little bit. There we go. So 5 times the square root of x plus 1 is equal to 5. I'm going to start by dividing by 5 to get rid of that coefficient out front. I'm left with the square root of x plus 1. 5 divided by 5 is 1. And now the radical's alone, so now I can square it. When I square it, I square both sides. The radical and the square cancel each other, so I have x plus 1 is equal to 1. I can then keep solving for x, subtract the 1, and I get x equals 0. So there's my solution there. I want you to go ahead and pause the video and see if you can finish number 8 on your own. And we're going to stop our notes video there for today. And don't forget to go back to Schoology and take your quiz. Have a great night, and we'll see you tomorrow.